Hello and welcome to PhDtalk. My name is Miriam and I'm the host on this podcast where I interview PhD students to let them talk about their topics and struggles and joys, and where me and others share tips with you to make your life as a PhD student more effective, less stressful, and most importantly, more fun. For today's episode, I spoke to Lærke Wester Larsen. Lærke is a PhD student at the University of Copenhagen, and she is part of an EU project called Lex for Bio, which aims to provide policy recommendations on transitioning from mineral fertilizers to bio-based fertilizers in a safe and efficient way. You might hear some rain in the background. It started pouring when we were recording this episode, and maybe even some thunder. I hope this feels rather calming than distracting. And then I hope you enjoy today's episode. If you have any questions, comments, complaints, leave them in the discussion section. We are happy to get back to you. And then let's talk science. Today's introduction is in Danish.
Jeg hedder Lærke, og jeg er i gang med en PhD ved Københavns Universitet på Institut for Plante- og Miljøvidenskab i jordfertilitetsgruppen. Og jeg er ved at færdiggøre min PhD, afleverer her slutningen af september. Så jeg er i gang med at samle det hele, alle mine resultater.
Hi, Lærke.
Hi, Miriam.
Thank you for taking the time for talking today to us and to everyone listening.
Thanks for inviting me.
Sure. Would you like to start introducing yourself? Like, what did you do before you became a PhD? What was your path towards applying for a PhD position?
Yeah, sure. So I think I've always been fascinated by nature. Sort of also had a fear for nature, a lot of respect.
Mm-hmm.
And I think so my passion for natural sciences started already when I was a kid.
And what was it that fascinated you, or what was it that scared you?
I think that's difficult to say. I think I've always just felt like if, for example, I'm at the coast looking out at the ocean, that it's just so big, that it's bigger than me. And whenever there was a thunderstorm, it was just, I was amazed and a bit scared of the powers.
Yeah.
That nature was just so much bigger than me. I think it was partly fascinating, partly also a bit scary.
Yeah, makes sense. Yeah.
Yeah. But I actually didn't plan to work with natural sciences from the beginning. I was very into drawing. I was one of the kids that never stopped drawing. Mm-hmm. So I wanted to become an architect. Yeah, so I spent all of high school getting good grades so I could get into the School of Architecture. And I got in, but it wasn't for me. And I could feel it immediately, but it took me a year to admit it to myself that that wasn't my place. And then when I finally decided that I was going to drop out, I also decided that I wanted to study geography, because that had always been my favorite subject. I had an amazing teacher in primary school in geography, so that had been my sort of natural science passion. Then I started studying geography. Yeah, geography is a field that not everyone knows, so maybe I can give my definition of it. So maybe it's a bit fluffy, but I like to see it as the connection between humans and nature. So how we as humans impact nature, and also how nature impacts us. So how we're mutually bonded.
Do you have an example?
Maybe agriculture is a good example. So we have manipulated the natural ecosystems to produce food, but we're also very dependent on the agricultural systems to function. You can also see a geographer as a Swiss knife. A geographer can do, just like a Swiss knife, a bit of everything, but it's not really good at anything in particular.
Okay.
But it has its strengths. So it sounds a bit negative, but then you can, so you combine all of the subjects, biology, physics, chemistry, social sciences, economics, and then you can see things in a new view that super nerdy biologists couldn't, because if you focus very much into a field, then you can't focus into every field. So there's a strength in knowing a bit about everything.
And connecting the dots between the different subjects.
Yeah, exactly. So that's at least what I really like about geography. Yeah, so I started my bachelor's in geography at the University of Copenhagen. I thought I wanted to specialize in the atmosphere and climate change. And then I was also very fascinated by the ocean at some point, but I ended up falling in love with the soil. Yeah. So yeah, and I continued a master's also in geography at University of Copenhagen, where I specialized in soil science and climate change. And then after that, I spent a lot of time as a climate activist and also looking for jobs. And then I saw this PhD position here at the University of Copenhagen, which I applied for. And now I'm almost at the end.
Okay. Nice. What is it that fascinates you about soil when you say that you fell in love with soil? Is there a why, or is it more of why do we fall in love? Not for any particular reason, I guess.
Yeah, good question, yeah. So I think it was very much related to agriculture, because agriculture is such a huge part of our lives. We all have to eat, and agriculture takes up a lot of surface area. And yeah, so I was very fascinated by how we can take care of the soils we use for agriculture, so we can keep producing food, but also so we can improve the ecosystems also for benefits of other organisms than ourselves.
And that also in view of climate change then, you see them related.
Yeah, exactly. Yeah, so soil is also very important for climate change. It stores twice the amount of carbon as the atmosphere. So in terms of climate change, it's also a very relevant field, definitely.
And then in your PhD, you could combine these two, the soil and the climate?
Yeah. Yeah, I could. Yeah. Yeah, so in my PhD, I look at bio-based fertilizers, and I focus on nitrogen, which is a very important element for all living organisms, and that includes plants. Yeah, so farmers, they apply nitrogen as fertilizers in the fields. And the fertilizers, the bio-based fertilizers that I study, are made of different waste materials. So it could be the organic waste from our households. It could also be animal bones or industrial wastes, organic waste. But all of them are organic, so they come from organisms originally.
So now in your PhD, you are part of a bigger EU project, right?
Yeah.
And what is that project about?
Yeah, so it's called Lex for Bio, and it is about bio-based fertilizers and creating knowledge about them. And the aim is to provide this knowledge for policy making.
And policies regarding giving recommendations to farmers, or giving recommendations to people producing the bio-based fertilizers, or all of it?
Yeah, so it's recommendations on how to regulate bio-based fertilizers. So farmers know how to use it. So they know how they work, how much they should apply, and how they should apply it. Should they can they apply it on the surface of the soil, or should it be incorporated, mixed into the soil? All of those specifics on how to use them.
So ideally, in the end, a farmer would be like, okay, I have that soil and I want to grow that crop. What bio-based fertilizer should I use? Okay, I should take this one. And then you're like, and you should surface apply it, or you should incorporate it. You should apply it June 5th. I guess that's too specific, but kind of
yeah, exactly.
those parameters.
Yeah. So you know, so both so the farmers get a good yield, but also so you don't end up with environmental pollution from using them. Yeah, and so in the project we have different work packages. There's one working on like the social economics of bio-based fertilizers, and then there's one working with soil quality, and one working with phosphorus, and then one working with nitrogen. That's the one I'm part of. And then there's one working with life cycle assessments, and then there's one working with pollutants. We cover different aspects, and then we work with the same bio-based fertilizers. So we have a list of almost 80 bio-based fertilizers in total, where half of them have a high content of phosphorus. So that's mainly the phosphorus people working with them. Then half of them have a high content of nitrogen. So that's mainly us working with them. And then there are some overlaps, and most of them contain both nutrients.
And then I guess in the end you would also have to know whether they like interact in some way, right? Like if they can just be applied together in any way, or maybe not. I don't know.
Yeah, so the nutrient balance is also important. So many of them are also composed of a mix of source materials. Many of the bio-based fertilizers we work with. Yeah, I mean it's also possible to sort of get the right nutrient balance based on what source materials that you then use. Yeah, or you would have to supply some extra nitrogen somehow if the nutrient balance is not right for the crop.
Yeah, sure. If I know when the nitrogen phosphorus ratio of this and this, then I know, okay, you can take so much of this and so much of this, right?
Yeah. Yeah, so with the mineral fertilizers, maybe it's not easy, but it's maybe easier because you have the minerals in pure form, and then you can combine them. But here you're dependent on the source materials, which have nutrient contents of which varies, and then you sort of have to puzzle it together.
Also getting it like in a homogeneous form.
Yeah,
I guess.
That too. And also some source materials vary more, so the product will differ with time. So that's also an issue. Yeah.
And then you look at the nitrogen in the fertilizers. And then what is it that you're trying to find out?
Yeah, so I focused sort of 3 different areas. So I've been looking at the fertilizer value. So by conducting a field experiment where I've been looking at how do they actually work as a fertilizer, how does the crop grow in the field, and then I've done 2 studies in the lab. And one of them was about ammonia volatilization. So that's sort of an environmental concern with these bio-based fertilizers, or potential environmental concern that I've investigated. And then I've also looked into soil quality, because these fertilizers, they come with organic material, most of them. They can potentially also benefit the soil quality. So I've also looked into that.
And how would you define soil quality? What is soil quality?
Yeah. So soil quality is all like, there are different terms for it, which are, they're different, but they're also related. So we also have the term soil fertility, soil health. Yeah, but soil quality is about how the soil functions, its ability to provide nutrients for plants, and also its ability to filter water.
So is function always related to agriculture, like the soil function or soil quality? Is that always looked at the view from agriculture?
No, not only agriculture. So it could also be related to the groundwater quality. Yeah, toxicity. So how it can buffer pollutants, and also how it affects biodiversity as well. So yeah, there are more like functions. So not only the agricultural use of it.
And how is soil quality then part of your PhD? How do you look at soil quality from your angle?
Yeah, so I've looked into how the bio-based fertilizers I work with affect soil quality. So I've chosen some different soil quality indicators that I've measured in the lab. And I set up an experiment where then I applied the bio-based fertilizer to soil and I let it stand for 1 year. And then I took out samples at 3 time points during that incubation period to see how the soil quality developed and how it was affected by the bio-based fertilizers. And I applied them at 2 different rates. So one rate which would be like normal application rate in the field.
What is the normal?
So that is what you would normally apply for a crop in the field for 1 year.
In relation to
nitrogen.
Okay.
Yeah. So based on total nitrogen content, because the fertilizers I work with are nitrogen fertilizers. Well, they also contain other nutrients, but I've focused on nitrogen. So I've calculated based on total nitrogen, and then I made like an accelerated application where I applied what corresponds to 20 years of annual application.
Okay.
Yeah. At once, exactly. To see how soil quality would be affected in the long run. So ideally you would do a long-term experiment out in the field and apply every year, and then see what happens. But since these bio-based fertilizers that I'm working with are very new on the market and haven't really been investigated a lot, I tried to do this simulation of long-term application. I included a soil that had been treated with compost for 17 years in a long-term trial, and compared it, because I had this compost, also the same compost product that had been applied for 17 years. I had this as well, so I applied that like at a rate of 17 years of application, and then I compared these two, and the results are a bit yes and no. So for some of the soil quality indicators, the lab setup that I made could predict what happened in the long term, but for others, not really. And also the question is if that applies also to the other fertilizers that I included, because they're also different from the compost. So, but I included it to get sort of an idea about whether it's it made sense. And the results from that study show that the bio-based fertilizers generally do improve soil quality, but it varies, and not all of the bio-based fertilizers improve all of the soil quality parameters, and there's also difference depending on the bio-based fertilizers.
So could you see trends or dependencies, or is there any general conclusions, or is it too?
It was actually a bit difficult to see trends. Yeah, but one thing that stands out is that the compost that I included was the bio-based fertilizers that improved the soil quality to the highest extent.
Okay. Was there something that surprised you on those results or on the experiment?
I guess I had hoped to get a bit clearer results. So it was a bit of a messy study. So I've spent a lot of time trying to figure out what the story was, because it was a bit here and there. Some of the fertilizers improved some parameters and not others, and then at some time points, but not at other time points. So it was a bit difficult. Yeah.
Okay.
And then it's a bit contradictory. So you have this compost that really improved the soil quality, but then in the field trial that I did, it gave really low yields. So they weren't different from the treatment I did, where I didn't apply any nitrogen. So it didn't really have a fertilizing effect, the compost out in the field. Yeah. So you can say you can't have both, maybe, like, yeah.
So then it improved.
Oh,
sorry.
No.
No, then it improved the soil quality, but that didn't reflect in the crop, right? And one would expect that if the soil quality improves, then you have more yields.
Yeah,
but that didn't
exactly.
show.
But that takes time, yeah. So maybe with time, the compost would probably have resulted in better yields, yeah. But this was only like one 1 year of application out in the field. So yeah, building up soil quality takes some time.
Yeah.
For most of the parameters.
So do you think that bio-based fertilizers will gradually replace mineral fertilizers, or are we far from that? Or is there actually enough bio-based materials that could function?
Yeah, that's a really good question. So there's definitely some political push to replace mineral fertilizers with bio-based fertilizers in the EU. So we just had this new fertilizer regulation, which includes the bio-based fertilizers. Previously they were in the waste regulation. So it's a new thing that now they are in the fertilizer regulation.
So that also means that those who generate that waste or have to deal with that waste before had to pay to get rid of it. And now they're getting money to get rid of it. Is that a result of that change or that shift in regulation?
I'm actually not too much into the to the economics part of it. But yeah, I mean, definitely things that were wastes before can now have a value as a fertilizer if farmers are willing to use them. So I guess that's the question, and that will depend on, I think, first and foremost, how they perform in the field. Farmers wouldn't be willing to accept that the yields are really reduced, then they would still use the mineral fertilizers. Yeah, from our field study, so we did one here in Denmark, one field study for 2 years, testing 10 bio-based fertilizers. Yeah, and then I'm part of an EU project. So we had in the project we had field sites at other places. So we had 4 field locations in general. We actually had 5, but one of them failed due to drought. Yeah, but the 4 of them we have results from. And the bio-based fertilizers in general performed quite well. So we calculated a replacement value. Yeah, so you have a reference of a mineral fertilizer in the experiment, and then you use that to calculate at the same application rate, total nitrogen application rate, how well do the bio-based fertilizers perform. And then you get a percentage from 0 to 100. So 100 would be that they perform equally well, and they can 100% substitute mineral nitrogen. But if you, for example, get 50% fertilizer replacement value, then if you want the same yield, you have to apply some mineral fertilizer, or you have to apply more of the bio-based fertilizers.
Okay.
Yeah. Yeah, and on average in our field trial at the 4 sites, the replacement value was 70%. It's quite okay, but it varied quite a lot. But actually half of them were above 75%. So quite a lot of them were in the higher end, but then there were also some in the lower end. And that was, for example, the compost that performed really poorly. Yeah. But we couldn't see any trends. So like we had hoped that then we could say, okay, this fertilizer, that works at all sites. It's very consistent. It has this high replacement value, but we didn't really see that. So the bio-based fertilizers that performed well at some sites performed poorer at other sites. So we didn't really see trends that we were hoping for. So there are still some things to figure out.
Okay.
Yeah.
So in the end, it would maybe make sense to know your site. And I guess what are those parameters, like the amount of soil or the share of sand in the soil, or like the texture of the soil. So then saying, okay, if your soil is really sandy, then you should use this or this or this bio-based fertilizer. But if your soil looks like this, then maybe try this type of bio-based fertilizer. And then we would have to redistribute all the bio-based fertilizers around regions.
Yes, exactly. Yeah. But with our data, we couldn't really distinguish that.
And then maybe getting back to the fertilizer value or the replacement value, does that mean if my value is like the 70%, as you said, or below or higher, that means that compared to mineral fertilizer, I'm losing 30% of my nitrogen, or what does that mean?
Yeah, so you can calculate it both based on the yield, so the grain yield you get when you harvest, but you can also calculate it based on the nitrogen uptake in the plant. Yeah, so it's a bit technical, but there are different ways to calculate it. But this one with the average of 70%, that's calculated based on the yield.
Okay.
Yeah.
Okay, so that doesn't mean that the rest of the nitrogen is lost, or not necessarily.
Not necessarily, but it could. Yeah. Yeah, so it's one thing that's difficult with the bio-based fertilizers is that they contain a lot of organic material, and then a lot of nitrogen in organic form, and that needs to be mineralized by the microbes to become available for the plants. Yeah, so you need the timing to be right, and if the timing is not right, then you have some nitrogen that becomes available after the plants have stopped taking up nitrogen, and that can leach to the groundwater or be lost in other ways. It could also be that you have some left the year after that can become available for the next crop. And we also tested that, and there was a small residual fertilizer value, so the fertilizer value in the next year wasn't statistically significant.
So that means that the timing of applying the fertilizer becomes more important than it is with the mineral fertilizer. Is that right?
Yeah, it is. And I think it's a lot about knowledge about it. So there's been a lot of research on mineral fertilizers, and they have been improved ever since they came on the market. And we have these slow release mineral fertilizers, and you need to know how it's released, different conditions, because it depends on soil moisture and temperature as well. Whereas the mineral fertilizers are less dependent on, or at least in theory, they are less dependent on the environment, I could say.
Yeah, sure. I guess with the mineral fertilizers, the system became more mechanistic, right? Less natural. So maybe that made it more predictable. And now if we want to shift to bio-based fertilizers, then of course we get maybe back to being it more natural. But then that might mean that we lose some, or that there's less yield or something. Yeah.
The question is then if you gain something, for example, with improved soil quality with time, if that's then worth it maybe. Or it could also be, so they contain organic matter, which contains carbon. So you could also get some carbon storage in the soil. So that could mitigate climate change. And so, there may be also other benefits of using the bio-based fertilizers. It also needs to be economically feasible.
And what happens to the bio-based fertilizers now? Like if they're not applied to the field? Just some examples, if you have some.
Well, so a lot of the materials that are used to produce bio-based fertilizers would have previously just been discarded as wastes. And now, there are also, it's not only fertilizers, it's also biofuels and producing biochar. There are many biomaterials have become popular for many reasons now. So I think we'll see increased competition also for bioresources.
Another thing that I was also thinking is, because for the mineral fertilizers, there's basically no storage issue, right? If I want nitrogen, I take it from the air and here you go, basically, right? But for the bio-based fertilizers, if I have to be quite specific on when I apply it, but I guess we generate bio-based fertilizer or bio-waste all year round, right? So would that mean that we have to store it for many months? Or could it mean that, okay, if we generate it during summer, it goes into a digester. If we generate it during winter, then we wait until we can apply it to the field? Or is there ideas like that? Or how about that? What is your...
Yeah, so the bio-based fertilizers that I'm working with, all sort of the products, they're processed. So with raw manure, you definitely have a storage and transportation and also a spreading issue because it's large quantities, and there are a lot of emissions from storage. Yeah, but with the bio-based fertilizers, then you can produce them year round and store them.
Mm-hmm.
Oh, yeah, because you sort of, most of them come in this like dried pelletized form, so they can keep, I mean, not forever, but they can keep for some time. Yeah, and you put them into bags, just like mineral fertilizers, and you can spread them using the same machinery as mineral fertilizers. So they are much easier to handle once they've been dried and pelletized.
Okay. And the volume is probably a lot bigger, right? Or is it not necessarily bigger?
Well, a bit bigger, yeah.
Okay.
It depends on the nitrogen content, of course. So some of them have quite high nitrogen content, and there, of course, you don't have that much mass. Yeah, but the quantities are a bit bigger, all of them, compared to mineral fertilizers. Yeah, for sure. So,
but that wouldn't be a big issue, you think, in terms of storing it, or?
No, I don't think, not with the ones with high nitrogen contents, no. But then, I mean, I've also looked at digestates, and there you have, I mean, many of the same issues as with raw manure, that they're liquid, and yeah. And you have a lot of mass because of all of the water. But then you can further process the digestates. I mean, there are so many different products, and there are new products coming all the time. So it's really, a growing market.
Yeah.
Yeah.
So I guess, so there will be more bio-based fertilizers. That is quite sure.
Yeah, I would say so. Yeah, because of the new regulation and the focus on circularity of bioresources and circularity of nutrients.
And do you think that you look at the world differently because of what you have been doing? Like, I don't know, when you read the news or when you see a field, or do you think you have a different view?
Yeah, I guess I do. Yeah. So maybe as an example, I've been, so I'm moving into a community in the countryside, and we'll have a small area for producing veggies and we are discussing how should we produce the food. And I think definitely I'm a bit like destroyed, if you like. Okay. Or like I know like you come with all of this knowledge, so I find it really difficult not to bring it in to the discussions.
Okay, but why wouldn't you?
Yeah, I also do.
Yeah.
But it's just, it becomes very, sometimes I feel like you take the freedom away. You just come and hammer them in the head and say, oh, you can't do that, that's not sustainable. And okay. But sometimes you also just need to remind yourself that you can't do everything like perfectly sustainable. But I think there are these things. I remember once my sister told me, so we just went to Netto to do some shopping, and and I had just been in the vegetable section for 10 minutes or something, or maybe she it's exaggerated, but I had just been looking at 2 broccolis and trying to figure out which one was the best option in terms of carbon footprint and environmental issues, and you can't, because I mean there's only so much information on the broccoli. So yeah. But I just tried to do all of the calculations, and then at some point I just decided that I was just gonna buy everything organic, and I wouldn't think anymore. It was just like, that's the rule. It was just to make it more easy. And then maybe, I don't know if it's sometimes better to buy apples, like conventional apples produced in Denmark, as opposed to organic apples from New Zealand or something. But I just take the organic, and then I don't think, because it's, it becomes too hard to think about all of these things all the time.
Yeah, true. Yeah. Also, packaged organic or unpackaged not organic.
Yeah.
Like one of my favorite dilemmas.
Yeah. It's tricky. But I also try to tell myself that I'm not responsible. Like, of course I'm responsible, but I see it more as that we need some system change. It's not up to the single person to make all of the right decisions. And anyway, you can't.
No, we don't have all the information.
No.
Yeah.
And we don't have the options in many cases.
Speaking of organic or conventional agriculture, in terms of bio-based fertilizers, can they go in any field, or is there restrictions, or how does that work?
Yeah, so I think that's also something. I mean, it's up to each country to implement the new fertilizer regulation, but some of them are already certified for organic farming. But yeah, I guess that depends on the input material, like what they're made of. Yeah, because that would be, I mean, particularly organic farmers, they really need nutrients. So that would be a huge advantage for them if they could have some nice fertilizers. Yeah, which are easier to handle.
Do you see any risks of using those, well, waste materials, if you want to call it like that, on farms or on soils?
Yeah, I mean, depending on the input material, yeah, for sure that could be some pollutants that we don't want in the field. And yeah, so in the project that I'm part of, we have a whole work package working with pollutants, investigating the bio-based fertilizers. That's definitely also a focus.
And what are such risks? What could be a risk?
So it could be heavy metals, antibiotics.
Because if I'm thinking in a really evil way, if there is now this loophole in, if we want to call it loophole, that some of the materials which were waste before can now be turned bio-based fertilizers, wouldn't someone be interested in maybe we can somehow label our waste in a different way and turn it into a bio-based fertilizer? Do you think there is a risk for that? For waste that is not actually fit for soil application, or?
I don't think so, actually, because they will have this CE mark. I don't know but many products have this CE mark, which is like a quality proof, if you like. So all of the fertilizers, all of the bio-based fertilizers will have this. So there will be some standards for them. So it's not just going to be like a free market where everyone can put anything in a bag. There will be like standards, and also you need to know how it works. So you need, as a farmer, you know how much to apply and when and how, and yeah. So yeah, there will be some restrictions, if you like, or guidance.
Yeah. Because already following the debate on whether we should apply like sewage sludge on the fields or not, there are so many pro and many against.
Yeah, exactly.
Finding the right way.
Yeah, and sewage sludge, I can't say that. Sewage sludge is not part of the fertilizer regulation yet.
Okay.
Because of this, so yeah.
Yeah. Okay.
That was decided that should not.
Okay. What is your vision if we think 40 years ahead? Where are we with bio-based fertilizers compared to mineral fertilizers?
I hope they have substituted a lot of the mineral fertilizers, and that we've gained a lot of knowledge on them, so we know how to use them without causing environmental problems, and so farmers can feel safe about using them.
Do you think consumers could be reluctant to that, like knowing that there is these products put on the field and then we eat the food that's coming from it? That people were like, oh no, I prefer mineral fertilizer.
Yeah, I think so. If you told them what they're made of. So if you told someone that you're eating something that's grown with animal bones.
Is that vegan?
Yeah, that's the question. Yeah. No, definitely. But if you don't know.
You don't care.
I don't know. I think there's also a lot of I know in Denmark. So in Denmark, organic farmers are allowed to use some conventional manure, and many, like, so they did some years ago. They did this. They went around interviewing people, telling them this. People who buy organic food, like really are really into buying organic food, and they got really surprised that was allowed. So I think definitely also knowing the input material of many of these bio-based fertilizers would maybe scare people. Yeah.
Would there be another label on our food? Origin of fertilizer?
I don't know. I think I see it more as you need some control that that pollutants don't end up in the food, and you don't contaminate the soil and pollute the environment. But when you've done that, I don't know. I personally think that people need to know, like, they need to know it's safe.
Yes, definitely.
But it's not that I think we should keep it a secret as such, but I don't think we should maybe have a label that, these apples are grown with dead animals. I don't think that's very constructive, maybe.
No, I don't think so.
Yeah.
I mean, we don't have labels telling people how pigs are raised, so.
No, exactly. Yeah,
right. Would you like to share some of your joys and your struggles doing your PhD?
Yeah. So it's had both. Both joys and struggles. I mean, it's been really exciting doing this PhD. Yeah, so I'm a very curious and nerdy person. So, which was probably also how I ended up here. Yeah, so I've just been really into what I've been doing, and I've had many days where time has just like flown by. Then it's 7 o'clock in the evening. Oh, I have to go home now because I have to eat. So it's been really, really exciting. But it has also been tough, partly, I think, because I've been quite ambitious. I guess all PhDs are quite ambitious. Things have taken much longer than I thought. And when I did my planning, there wasn't really any room for things to fail or things to take longer time than they do. And they've all done. I mean, that's also what research is about, that things fail and then you try it in a different way and you succeed, and things aren't as straightforward.
No. Especially since you're working with nature, I guess.
Yeah, and you have to set up a new experiment and figure out how you can make things work. And it just takes so much time, and much more time than I had thought. Yeah, so I think that has been tough. And then I've also felt sort of trapped sometimes. Then you've planned this experiment and you've started it, and you also have other things to do. So, for example, I've been both in the field and in the lab, and you also have to do some writing and attend courses. And I mean, there's so many things. So it's not only one thing at a time. And then you've set aside 2 weeks to do an experiment in the lab, for example, do part of an experiment in the lab, but then it just takes so much longer, and you can't just extend it. So you end up staying very long nights for many days, and that has been quite exhausting. So I think if I were to do it again, with all of the knowledge that I've gained, I would be a bit less ambitious. Plan smaller experiments. In general, just do a bit less, because it was a bit too optimistic.
I guess many start like that, but maybe we all have to go through it.
Yeah, I think so. Maybe, yeah.
Part of the journey.
I guess also if somebody had told me, then maybe I wouldn't really have listened.
Yeah.
Because I just wanted to do everything. Actually, I wanted to do way more than I ended up doing. So I think it's difficult because you have this drive. You really think that is so interesting. So it's difficult.
I guess it's good to be ambitious in a way, but then not to go too far.
Definitely. And then I've kept track of my working hours. That has really helped me. So when I've had these long days in the lab, then whenever there was a period with a bit more time, then I took a day off.
Okay.
And yeah. And so I think it has really helped me, like, seeing it in numbers. That, okay, I've actually worked 2 weeks overtime now. I have to take some shorter days or some days off.
Yeah, it's good to keep track of that.
Yeah.
Also to allow oneself to then go home earlier, because otherwise you're like, no, I still have to stay until, I don't know, 5 or 4.
Yeah, exactly.
Even though I know I worked too much last week.
Exactly, yeah. At least I'm like that.
Yeah.
So, but yeah, I knew that about myself when I started. So I started keeping track of the hours actually from day one.
Then I have a few remaining questions, and you can answer them very fast. And it will be over very fast. In the morning or in the evening?
I guess in the morning.
Okay.
If you refer to when I'm most productive.
I'm not explaining anything.
Okay.
Coffee or tea?
Both.
Both. Okay.
Do I have to choose?
Usually you have to choose.
Okay. Then I choose coffee.
Okay.
But it's difficult.
It's difficult. Canteen or lunchbox?
Lunchbox.
Science or nature?
Science or nature? Oh, that's a difficult one. I guess I would have to go with nature.
Nature. Nature or art?
Nature again.
Okay. Twitter or LinkedIn?
LinkedIn, I guess. I don't have Twitter.
Okay. Then that's an easy question.
Yeah, I'm not a huge social media person.
Okay. You don't have to. Then if you don't have anything else that you'd like to share, then we call it an interview.
Thanks.
Yeah, thank you very much for today. Thank you.
Thank you.
I hope you enjoyed today's conversation. Welcome back. I hope you learned something new, not just about bio-based fertilizers, but maybe also about geography and our world in general. Thank you for listening. Thank you for your time. I am looking forward to welcoming you here again for the next episode. Until then, I wish you all the best. Yours, Miriam. Bye-bye.